Alright, today we're going to take a look at the Testo 510 differential pressure manometer with protective cap, batteries, and calibration certificate. All of the pocket line instruments have a protective cap that's integrated right onto the instrument itself. A simple push with your thumb here, it breaks the cap loose. We can take that cap, we can slide the instrument right inside for single hand operation. Also, if you want to stick it to a furnace or back to the piece of ductwork, it's got a magnetic back. The instrument itself uses two AAA batteries. It has a typical life of about 6 months. Sometimes you get a little bit longer out of it depending on how frequently you use it. Back goes right in and snaps on. Typically, differential pressure manometers are used for static pressure, pressure drops across filters, air velocity in feet per minute, gas pressures, draft, or any other kind of differential pressure reading you might want to take. The 510, even though it's a small instrument, is really quite feature rich. The 510 has several built-in units, and I'll show you how to get to those. I'm going to go ahead and shut the unit off for a second. We'll turn it back on, and what's going to happen is I'm going to come up to a screen that allows me to select the units. So I'm going to zoom in a little bit here so you can take a look closer. And as we zoom in, alright, you can see we're flashing inches H2O. Now I have an up arrow key, which is my select button, and I have an enter key over here, which is going to allow me to lock that reading in. If I hit the select button, you can see inches H2O is flashing, and we go to inches of mercury, meters per second, which is a velocity reading, feet per minute, which is also a velocity, hectopascals, millibar, pascals, millimeters H2O, millimeters of mercury, PSI, and then back to inches H2O. I'm going to go ahead and select inches H2O because that's typically what contractors use for making static pressure or gas pressure measurements. When I hit that button, now next comes up the auto off feature, which we're going to leave on. The auto off feature will keep the battery from expiring prematurely. We'll go ahead and hit enter again. When the instrument comes up, it's re-zeroed now and is set to inches H2O. If I wanted to null the sensor, I just hold the up arrow down for a second and it'll re-zero. It basically is telling the instrument there's no pressure on the sensors and taking it back to zero again. All of the pocket line instruments incorporate a backlight. You can see when I hit the on key, the backlight comes on and it allows you to easily see this thing in dark areas. If I hold the backlight again, it'll shut the whole instrument down. So that's your on and off key. Now when we turn it back on again, you can see it came right up to inches H2O and there's no need to redo the configuration method. A couple nice things about the Testo 510 are that it's got temperature compensation, a magnetic back for hands-free, it does velocity measurements with a pitot tube, air density compensated, it's got a protective cap, a wrist strap, and a backlit display. So these are what make the instrument unique and one of the best values in the industry right now. The things that makes the Testo 510 unique is its ability to measure airflow with a pitot tube. When you're measuring airflow, what you need to do is we're going to turn the unit off for a second and we're going to bring it back up and get the units to feet per minute. So I'll hold the on key. You can see I'm back up here at inches H2O. I'm going to zoom in so you can see the display a little bit. And we're going to toggle till we get feet per minute. We're going to go ahead and hit the enter key. When we hit the enter key, it comes up with air density. And air density is simply the pounds of air per cubic foot. So right now typically we have 0.075 pounds per cubic foot. So you can see the zeros flashing. That's the unit I can adjust with the up arrow key. I'll take it back to 0. And then I hit enter. It goes to the next unit. I hit enter. We're going to go ahead and change this to 0.075. We'll hit enter. And now we have the air density input into the meter. Hit enter again. And now the meter is reading velocity in feet per minute. I'm going to go ahead and just touch my finger to the top cap here and we'll get a velocity reading. And you can see that it's reading velocity directly, 1900 feet per minute. Okay, I take my finger back off and it goes right back down to 0.